Hello, my dear students, and welcome back. I know, exams are just around the corner, and this chapter on light, shadows, and reflections can sometimes feel a little tricky. But please, don't you worry one bit. I'm here to help.
Seeing all those books, the tension builds up, doesn't it? But really, there's no need to stress. Just take a nice, deep breath because your favorite tutor is here, and we're going to make this chapter absolute piece of cake.
That's right. In just the next few minutes, we're going to revise this whole chapter so well that it will literally become your exam superpower. You'll be able to answer anything they throw you. So, are you ready? Let's do this.
Okay, let's dive right in. We always start with the basics, right? The absolute fundamentals. So first up, let's talk about where light even comes from. It's very simple, beta. Some objects, they're like superstars. They make their own light. We call them luminous objects. Like the sun, a light bulb, or even the pole star. And then you have other objects, like our dear moon, that are non-luminous. They don't have any light of their own. They just reflect light from a luminous source. So the moon is only shining because it's borrowing the sun's light. Simple, Hannah?
Now this one is a super important rule. Light travels in a straight line, period. Just like that activity in your textbook, if you look at a candle through a street pipe, you can see the flame perfectly. But the second you bend that pipe, poof, the flame is gone. And why? Because light just can't take a turn. It travels straight and true.
So let's have a quick exam checkpoint. Look here at Sahil, Rika, Patrick, and Kasima. Who do you think can see that candle flame? Come on, take a good look at their pipes. Yes, it's Rika, of course. Why? Because her pipe is the only one that is perfectly straight. Brilliant!
Okay, so we've established light travels in a straight line. Now what happens when that light actually hits an object? Well, it all depends on what the object is made of. First up, we've got transparent materials. Think of a clean window glass. You can see everything outside crystal clear. That's because transparent objects let all the light just pass straight on through. No fuss. Next is translucent. Now, this one's a bit of a mix. Some light gets through, but not all of it. So you can kind of see what's on the other side, but it's all blurry and not very clear. Tracing paper or a frosted bathroom window, perfect examples. And finally, we have opaque objects. These guys are the big blockers. They don't let any light pass through at all. Think about your textbook, a thick wall, a piece of wood. You can't see through them. And this is a very important idea because when light gets blocked, something really interesting happens.
And that interesting thing is a shadow. That's right. When an opaque object stands in the way of light, it makes a shadow. Let's see how that works.
This picture here explains it perfectly. We have a light source, the torch, and an opaque object, the football. The ball blocks the straight path of the light, and it creates a dark area right behind it. That's your shadow. So remember, to see a shadow, you need three things: a light source, an opaque object, and a screen for it to fall on. Let's test this out. This is a classic question. Imagine this whole setup. What do you think happens to the shadow if we move the torch closer to the ball? And what if we move it farther away? Just think for a second. And here is the answer, all nice and clear for you. When the torch is close to the ball, the shadow gets larger. But as you move the torch farther away, the shadow becomes smaller. And of course, if you just remove the ball, well, there's nothing to block the light, so you'll just see a bright spot on the screen. See? So simple. All right, we've covered light sources, materials, and shadows. Now, for everyone's favorite part, mirrors. What is this magic that happens when you see yourself in a mirror? It's something called reflection. Now, an image in a flat or a plane mirror has some very specific properties you must remember for your exam. First, the image is the same size as you are. Second, it's upright, it's not upside down. Third, you can't actually capture it on a screen. And fourth, and this is the tricky one, it's laterally inverted. So what on earth is lateral inversion? It's just a fancy way of saying left-right reversal. Look at this. When you raise your left hand in front of a mirror, your reflection looks like it's raising its right hand. It's like the image is your twin who does everything opposite, but only from left to right. And that's exactly why the word ambulance is written backwards on the front of an ambulance van, so that other drivers can read it correctly in their rear view mirrors. Cool, isn't it? Now, let's use what we've learned to understand a very cool, very old device, the pinhole camera. It uses that straight line property of light to create a real image.
The way it works is just amazingly simple. Light rays from the top of an object travel in a straight line, go through that tiny pinhole, and land on the bottom of the screen inside. And the rays from the bottom of the object go through the hole and land on the top of the screen. So what's the result? The image is completely upside down, or what we call inverted.
Just look at this diagram from your book. The tree is standing upright, but the image that's formed inside the pinhole camera is clearly upside down. It's a fantastic, real-world proof that light travels in straight lines.
Okay, my champions, you have all done so well. It's time for a final, quick revision. A little power-up to make sure all these concepts are locked and loaded in your brain for the exam. Let's go.
Let's try this match the columns exercise together. Pinhole camera. It forms an inverted image. Correct. Opaque object. It blocks light completely. Correct. Transparent object. It forms a dark region? Wait a minute. No way. A transparent object lets light through. It's the opaque object that forms a shadow. See? You have to be alert. So the correct match for the dark region would be a shadow, which is formed by an opaque object. And before we finish, here's a totally fascinating fact for you to remember. Light is incredibly fast, but space is just mind-bogglingly big. It actually takes sunlight over 8 minutes to travel all the way to us here on Earth. So, if the sun were to magically just vanish, we would still have sunlight for another 8 minutes and 20 seconds. Isn't that just wild?
And just like that, we're done. See? You're a total pro at this now. I am so proud of you. You've revised the whole chapter, and you are 100% ready. Now go into that exam hall with full confidence and just ace it. You've totally got this. All the very best.